Dear colleagues, dear students, and dear fellow participants, this is Dr. Roar Goven. I'm an aerospace and nuclear engineer, and happy to be here in the International Astronomical Congress Digital Edition in 2020. I want to make a presentation about my paper on nuclear power generation using helium-cooled reactor for moon habitats. Obviously, moon has been a very important part of space exploration since NASA was able to send people to the moon in 1960s, 1969 to be exact. It has been an important accomplishment because moon is the stepping stone to the other parts of our solar system. If you want to have a feasible Mars mission, having a lunar base on moon would make this very easy. It can be used to launch missions to almost every part of the solar system because now you don't have to worry about the gravitational constraints of the gravity of Earth. So being on the moon would give you a tremendous advantage in not only conquering the lunar surface, but also conquering the remaining parts of the solar system. But the problem with having a lunar base is, first of all, you need a lot of energy. Moon is not a very hospitable place, as you know. It's very cold. It has 1/6 of the gravity of Earth. You need a lot of energy to support the life support systems. You need a lot of energy to keep it warm. You need a lot of energy to perhaps change the lunar ice into water and hydrogen to be used. So all of that requires a lot of energy. So how do you create this energy? First of all, it needs to be durable and continuous under lunar conditions. That means even under those harsh conditions, the energy production should be continuous. Even under lunar night conditions, it should be able to still generate power. It should be able to operate under reduced gravity, vacuum, extreme colds. It should have an output of enough power for life support, heating, base systems, lights, production facilities. Only then we can actually say mankind has a real footprint on the moon, and therefore mankind can have a footprint in the remaining of the solar system. So one of the ways to do that is to have a nuclear reactor. A nuclear reactor on a lunar base would actually have the capability to meet all of the checklists that you can see on this particular slide. But obviously this can't be a regular reactor like the reactors we have on Earth because first of all, you don't have access to large amount of water. You don't have a water supply to dump this water when you finish the cycle. You need something much more advanced, much more modular, and you need something which is much more safe and which can be operated under these conditions. So my suggestion is to use a helium-cooled nuclear reactor. It's actually a supercritical nuclear reactor that works by the circulation of helium. You can see in the particular slide that you have those fuel elements, you have helium. Helium, as you know, is inert gas. It doesn't go into a chemical reaction with almost majority of the elements. Therefore, it's chemically safe. It has a very high transfer heat coefficient. Therefore, transfer of heat from the nuclear reaction to the helium is also much more. As you know, for those who are having a background in nuclear engineering, higher heat transfer means that you're able to extract more work out of the nuclear reactor. Therefore, it has a lot of advantages. You're able to extract more work. It's more safe. You don't have the possibility of explosion due to H2O dissociation at high heat, and you don't need water most of all, which is difficult to find on the moon. And you could recycle the helium again and again and again for this particular for this particular reactor. And most importantly, there are large amounts of helium found on the moon, helium-3 to be exact. It's an isotope of helium, but it can also be used in this particular reactor as well. So what are the fuel elements used in such a reactor? Instead of the normal nuclear fuel rods that we come to know, the big long sticks that you have perhaps seen in some presentations, we use small spherical fuel elements, which is basically the size of a tennis ball, You stack them together and you pass helium through them. The nuclear reaction starts. You bombard them with neutrons to start the nuclear reaction, and then you transfer the heat to the helium, which acts as a coolant as well as a safety device. So advantages would be, as you can see from the presentation, it's an inert gas, it does not corrode, it works well under reduced gravity of the moon, it doesn't become destructively critical, so in case of an emergency or in case of a problem that happens, you don't have to worry about explosion like you would have worried about on Earth. It has a higher heat exchange coefficient, and since you don't have water on the moon, this would be a good feasible way to use something. So this is a typical moon base with helium cooled reactor. You would put it into the opposite end of the moon base, connect it as a power supply. It could be used for a variety of methods, and it would allow mankind to have a footprint on Earth. So thank you for listening to my presentation. My website is www.drgovan.com, or you can listen to my website, also mine, www.aerospacelectures.com, or you can email me on this issue. I've been working on it for some time. I'll be happy to connect with you. Thank you very much, and enjoy the rest of the International Astronomical Congress.